Hello class, so we'll like to look at the second part of the solutions. So let us look at the first question, as you can see here. So that is the expression which we need to take the derivative of. The concept which we'll be using is the implicit differentiation. Alright, so first A. So here we have y cubed plus 3x squared y plus 13 is equal to 0. So when you take the derivative of the first part, we're going to get 3y squared times dy dt, or dy dx, sorry. And then, in case of second one, you should be able to see the product rule right over there. So what's going to be happening is this, plus 3 x squared times dy dt, dy dx, oops, and then plus y times 2x, derivative of x squared. Then we get to realize that plus 0 is equal to 0. Now, here we can have the terms with dy over dx. So let us look at the let us factor out dy over dx. And we have 3y squared plus 3x squared. Now, but as you can see from here, 3y times 2x would have been gone to the other side. So we have negative 6xy. Then, of course, dy over dx would make it go to negative 6xy, divide whole thing by 3y squared plus 3x squared, which we can simplify further by dividing top and bottom by 3. We have negative 2x times y divided by y squared plus x squared. Alright, but an equation of the line tangent. Now, in order for us to see the line tangent, we'll be needing two pieces of information, slope and the point, but we know the point. And we should be able to figure out the slope from the first derivative, which is right over here. And I was looking for that. Now, B. Since the point was 2 comma negative 1, I believe, our slope should be equal to negative 2 times negative 1, and then negative 1 squared plus 2 squared. And here we get, on the numerator, we get 4 over, denominator, we get 5. So slope becomes 4 over 5. Now, then what we end up getting is the equation becomes y plus 1, 4 over 5 times x minus 2. This becomes the equation of the tangent line. Alright, find the minimum y coordinate for any point on the curve. Now, how would you find out the minimum? So to find that value, we get to realize uh, minimum y coordinate is simply the minimum of the curve. So what we like to do is this. We like to figure out the point where this will be equal to, first derivative will be equal to 0 or not defined. We realize that dy over dx will be equal to 0. That means the numerator has to be equal to 0. So negative 2x y. And in this case, we know that this will be true if x or y is equal to 0. Now this will be undefined, meaning denominator is equal to 0, x squared plus y squared. That's if x and y are equal to 0. But let us see what's going to be happening if x or y is equal to 0 based upon the expression that we see, original equation. So from the original equation, y cubed plus 3x squared times y, I believe the expression is plus 13 is equal to 0. If x equals 0, what would have happened is this middle term becomes 0. So therefore, we're going to have y cubed plus 13 is equal to 0. There we get to realize that y must be equal to cube root of negative 13. In other words, simply negative cube root of 13. That's what we end up getting. Now, if y is equal to 0, then we simply get 13 is equal to 0, but that's not possible. So therefore, y can never be equal to 0. Then it seems to be that we only get one value right over here. Then let us look through that. So when x equals 0, y seems to be negative radical, negative cube root of 13. If you do the number line, just to see if it becomes the minimum value or not, here x is equal to 0. Now, when x equals 0, by looking to this one, knowing that y prime is equal to negative 2 xy over x squared plus y squared. If x equals negative value, then we realize that the expression will be positive. Of course, y is given that y is positive. And when x is negative, given that y is positive, then this will be equal to negative. But you will realize that, as you can see from here, if you were to modify this expression, you will realize something quite interesting. Here, if you factor out y, for example, then you're going to get y squared plus 3x squared. And then by moving 13 over to the other side, we get negative 13. That means this portion will always be positive. Only way for this expression to be negative is if y becomes negative. So one thing that which we can assume is that y has to be negative at all time. So from this expression, this would have been true if y is positive. But since y is negative, when x is negative, then this portion will be negative. When x is positive, the slope will be also positive. That makes, when x equals 0, that to be the minimum value. Right over here. So x equals 0 and y equals negative cube root of 13. Alright, let us move on to the next question. Alright, so we're looking at number 5 here together. Let's so given that this is the expression, and we are looking for limit as x approaches 0. Now, in case of number 5, it will be better if you had to simplify this one as much as we can. So the numerator can be factored out by x. And we will have x squared minus 1 left. And then denominator becomes x and x squared minus 4 left. Then this expression now will be factored further, x and then x plus 1 and x minus 1. Here, x and x squared, oops, minus 2 and x plus 2. Alright, so then we get to realize that x can easily cancel out, and we'll have this the middle portion right over here. This is the rather simplified expression for f of x. Now, given that a, find the limit of f of x as x approaches 0, we can simply use the middle expression. That's the same as limit as x approaches 0, x squared minus 1 by canceling out x's, and then x squared minus 2, minus 4. And as x approaches, what we'll end up getting is simply 1 over 4. That will become our answer. Now, second, find the zeros of f. Then we can set 0 equal to the expression, since once again x cancels out, we have x plus 1 times x minus 1 all over x plus 2 times x minus 2. Now, then here we end up getting, in order for the fraction to be equal to 0, the numerator has to be equal to 0, so therefore x must be negative 1 or positive 1. Write an equation for each vertical and horizontal asymptotes of the graph. Now, vertical asymptote is when the denominator is equal to 0. Well, you can see that here we have when x is equal to 0, since it canceled out, it simply becomes a hole in the graph. The vertical asymptote will be when x equals 2 or x equals negative 2. Now, horizontal asymptote is when, as x approaches positive or negative infinity, then, as you can see, as x approaches positive infinity, this expression will be approaching simply 1. But as x approaches negative infinity, as you can see from here, y will be equal to still 1. Negative over negative is positive, so we're not going to write the second one. It will be simply y equals 1. Alright, now describe the symmetry of the graph of f. one thing which we can do is this symmetrical about the x-axis or y-axis, or about the origin? Obviously, it cannot be symmetric about the x-axis. Now, to do that, one thing which we can do is to see if this one is a even function or odd function. So when you plug in f of negative x, then we get to realize that here, hey, then it becomes negative x cubed plus x over negative x cubed plus 4x. Now, this basically is equal to negative f of x. So therefore, we realize that this is the odd function. Meaning, this is symmetrical about the origin. All right, and that is number 5. Let's move on to the next question, number 6. So that's the expression that we have. Write an equation of the horizontal asymptote. Now, horizontal asymptote in this case, let's try to put it as limit of that expression. I'm going to write it as 2x over e to the x because of the negative exponent as x approaches positive infinity or negative infinity for that matter. Now, if as x approaches positive infinity, what's going to be happening is top and bottom will approach infinity. But since the exponential function increases more rapidly than the simply linear function, therefore this will approach 0. Now, so therefore we get to realize the horizontal asymptote will be y equals 0. Now, B. Find the x coordinates of its critical point of f. Now that means since this expression will never be undefined, so therefore we're just gonna we will be looking for the place where this will be it has its derivative equal to 0. So in order for us to do that, f prime, let us try to look at the product rule in this case. And we have 2x times negative e to the negative x plus e to the negative x times 2. Now, then if you take factor out negative e to the negative x, then we get to realize 2 from here minus with the sign 2x. And here we get to realize that can this ever be equal to 0? Yes, because this portion, since this portion will never be equal to 0, 2 minus 2x will be equal to 0 if x equals 1. Now, when x equals 1, then let's try the simple sign analysis. When x is actually greater than 1, no matter what, this will always be positive. When x is greater than 1, this expression will be negative. And when x is less than 1, this expression will become positive. So positive and negative, that means this will be relative maximum. Now, that seems to be the only value. Now, for what value of x is the graph concave down? So concavity will be found by double derivative. The second derivative here. That means I'm going to try to do the calculate one more time from here. So we have e to the negative x times the derivative of this expression, which will be negative 2. And then plus 2 minus 2x times the derivative of that would be once again negative e to the negative x. Now, by factoring out the e to the negative x, we get to realize here negative 2 and minus of that negative 2 plus 2x. Then when I simplify this one, e to the negative x, here we have 2x minus 4. Now, this can be equal to 0 if x equals 2. So that means when x equals 2, by doing the simple sign analysis, when x is greater than 2, we get to realize that concavity is positive. When x is less than 2, concavity would be negative. So therefore, yes, point of inflection is when x equals 2. But we are looking for the area where we have negative concavity. So negative concavity is when x is less than 2. Alright, so let's go for number D. Using the result from part ABC, we'll try to sketch the graph on the axis provided. So here we have negative 4 to positive 4. Then we'll try to pick up a couple of important points, such as when we're going to make a small chart. Oops. I meant small. So I'm going to try to bring this one down here. So x can be, this is x value, this is y value. So negative 4, starting point, that's very important. And then 1 is also important because that's a critical point. And 2 is the point of inflection, and then 4 will be the other point. So when x equals negative 4, we can plot in the value right over here. It becomes 8 times e to the 4th power, which is very, very, very large number. I get to see that. Oops. Actually, we have negative 8. And when x equals 1, then we have, when x equals 1, we have 2 times e to the negative 1. Then this becomes 2 over e, basically. So this is about 2/3, because e is equal to 2.718. Now, when x equals 2, we get 4. 2 times 2 becomes 4. 4 over e to the square. And then e is the 2 point. So this becomes about half. And when it's 4, we get to realize that this becomes 8 over e to the 4th power. Now, one simple value which we can calculate is when x equals 0. Then y value will be also be equal to 0 because of the expression. Then let's plot those points in. And then when 1 as you mentioned, it's going to be about 2/3, so it's going to be around here. When it's 2, it's going to be about half. And when it's 4, it's going to be even smaller than that. So first, we get to realize that the function will be somewhat up to here will be negative concavity. Let me try to redraw that from here. But from here to here, it's going to be positive concavity. Something along that line. It was difficult to draw, but this one has to be more straight, coming up in this way. So that will be our answer. All right. So I believe that with that, we have the number 6. That's it. Have a nice day. Bye-bye.